Hi everyone, welcome back to another discrete time linear problem. Today we're going to be solving for problem set 4, where our goal is to find our y sub t. So with the input x of t, with these h of j omegas, we're going to first solve for h of a, and then we're going to solve for it with h of b. The good thing about this is that once we solve for our a sub k coefficients, we could use the same coefficients for h of a and then for h of b and for whatever problem that we have. So first, here is our game plan. Our goal is to find our a sub k, where we need to find our period. So when we're looking at our period, we can then see from going from -4 to 4, which is a period of 8, which we can then find our fundamental frequency. So now if we look at it, our fundamental frequency can be from omega naught equals to 2 pi over 8, which is just pi over 4. I made a mistake in my calculations where I used 12 as a period, but as we know now, our fundamental frequency is pi over 4, right? So then we're going to set our regions and solve for our a sub k over 1 period from -2 to 2, since that's the easiest one that we can do. And then from then on, we're going to find our b sub k, which we're using our a sub k coefficients and multiplying by h of jk omega naught, which when we plug it in, we are going to use this function right here. And then from then on, we are going to be able to find our y sub t, which is just the sum of our b sub k times e to the j k omega naught t. So now when we jump straight into it, here, like I said before, got the wrong period, but we're going to still go with it, right? So we're going to solve for our a sub k, which we could then say that our a sub k is a sinc function with sine pi over 3 k over pi to the k, and that's going to be our sinc function. From then on, we're going to solve for our b sub k with h to the j k omega naught. As we know, since we plug it in, we're going to have this going from pi over 3 to all the way to negative infinity. We're then going to solve for our coefficients and get our b sub k. From then on, we could then solve for our y sub t by solving for the sum of our b sub k's from negative infinity to positive infinity, which will then give us our y sub t, which equals to y sub t, which is this equation right here. We then repeat the same process to solve for our h of b, which goes from pi over 5 to positive infinity. And just like that, that's just how you solve it. Come back again.